Hi all, electrical engineer, Igor Ekimov, is with you. Today we will look at the HRM-10 battery internal resistance tester from FNIRSI. But the capabilities of the device are not limited to this. It can measure not only the internal resistance of the battery, but also the usual resistance from 1/100th of a milliohm to 200 ohms and constant voltage up to 100 volts with an accuracy of 0.5%. They can test almost all types of batteries, as well as check the quality of connections, the quality of contacts in switches, and determine the real resistance of the wires, even if they are short. The same device can sort batteries according to specified parameters. I'll talk about this further in the video. If you are interested in device reviews, then subscribe to the channel and press the bell. Special thanks for your likes and reposts. The device comes in such a beautiful package, even as a birthday present. This is FNIRSI's calling card. They pay great attention to packaging. Plus, they also care about the quality of their devices. The box was still packed in cellophane, which I had already removed. The characteristics of the device are indicated on the back of the box. You can stop the video and look at them in more detail. The accuracy of the device has been tested by other bloggers and its performance is as advertised. Open the box. On top is the passport for the device. It is in several languages, including Russian. The datasheet describes the device quite briefly. Watch the video to the end and you will find out the information that is not in the passport. There is such a yellow square. This is a kind of quality control department sign from FNIRSI. The device is packed in polyethylene foam, which increases the safety of the device during transportation. We remove the box together with the device. Below it are Kelvin probes and a cord for charging the device. The charging cord is 0.5 meter long, with USB and Type-C connectors at the ends. There is no charger included. This cord can also be used to update the device's firmware and transfer saved measurements to a computer. Kelvin probes deserve a more detailed look. These are no ordinary crocodiles. Each such crocodile has at least 2 wires. Each wire goes to its own probe contact. One wire to this pin, the other wire to this pin. These 2 contacts are isolated from each other. There are a total of 4 wires going to the probes. They go to the 4 pins in the connector as you can see. This results in 2 current wires and 2 voltage wires. We will not deal with the physics of the process, since it is not simple and will take a lot of time. The peculiarity of this 4-pin connection is that it allows you to measure voltage and resistance with great accuracy. In addition, the device generates a test signal with a frequency of 1 kHz, and as a result we get accurate readings on the device display. Let's look at the device itself. In the middle is the keyboard joystick. I will show you how it works in practice. We hold down the middle key for a long time, and the device tests itself and turns on. We see a large display with large numbers. The display is easy to read from different viewing angles. Voltage and resistance are displayed simultaneously. The time and date are displayed at the top. There is also an icon indicating that the sound is on and the device's battery charge level is shown. If the charge level becomes less than half, it is recommended to charge the device. On top there is a connector for connecting probes. As I said, there are 4 contacts. On the side there is a Type-C connector for charging the battery. The battery here costs 1000 mAh. How long this charge will last is not indicated. Any 5-volt, 1-amp charger with a USB output will do. Through the same connector, you can update the firmware and transfer saved device data to your computer. There is an LED window here. It glows red when charging. And here you can use a pin to reset the device when it freezes. And this is what the device looks like from below. There is a hole to hang the device. But the peculiarity of this device is its rubber feet, which allows the device not to slide on the table. The developers with FNIRSI went even further, and they installed rubber feet here too. We fold back the leg and place the device. And the device does not slip due to these legs either. And in this position it is convenient to measure with the device. We fold the leg and put it down. The device also rests well on the rubber feet. Let me show you how to operate the device, and then we'll study its menu. We connect the probes. The connector is round. There's a key here, and there's a key in the dipstick. We combine the keys. Insert and tighten until it stops. The device is ready for use. Although this device is promoted as a battery tester, I am more attracted to its low resistance measurement function. You can measure the resistance of shunts, wires, contacts, and the quality of connections. For example, let's take this wire. These wires are sold in packs on AliExpress. I connect the probes directly to the half of the crocodile to which the wire is connected. We measure 662 milliohms. Such a small wire, and the resistance is almost 1 ohm. I think this is a lot, and I'll think again whether to use such a wire for my circuits or not. Here we take a wire, a quartet of copper, crimped on both sides. Resistance 4.25 milliohms. You can already work with such a wire. When purchasing a cable coil, you can use this device to measure the resistance of the cable cores and compare it with the table. If the resistance is greater than that given in the table, this means that the copper either has a lot of impurities, or it is a truncated wire. That is, a wire with a cross-section smaller than the declared one, and you need to think about whether such a cable is worth buying. This device will help if you need to make a shunt of the required resistance. As you know, even a modern multimeter does not measure less than 0.1 ohm. Moreover, at small values, it has a very large error. But with this device, making a shunt is not a problem. Here we have a non-chrome wire. We connect one probe to the end of the wire, and move the second one. As you can see, the further from the end of the wire, the greater the resistance. Select the desired resistance and cut the required length of wire. If you need to adjust the resistance of an existing shunt, then this is also not a problem. And you don't need to do this by eye, or take additional measurements after amplifying the shunt readings. The process of adjusting the shunt resistance becomes much easier. Using this device you can determine the resistance of the switch contacts. Here is an example of a Chinese switch. Turn it on. This shows us the contact resistance of the switch. Turn it off again. Let's turn it on again. We look at the resistance of the switch contacts, about 10 milliohms. If we have several switches, and the minimum contact resistance is important, then with this device we can select the best switch. Let's take a limit microswitch. Let's connect. We press. The resistance is about 8 milliohms. Here we press again. Again 8 milliohms. I believe that such readings are normal. There are cases when the resistance shows ohms, or even tens of ohms. These switches need to be replaced. You can also test the relay contacts. They tend to burn over time. We connect the probes to the contacts. We apply the relay operating voltage to the winding. And depending on the results, we either leave the relay in the circuit, or clean the relay contacts, or even change it entirely. The device measures the internal resistance of all batteries. According to Ohm's law for a complete circuit, the voltage at the battery output depends on its internal resistance. According to the formula, the output voltage is equal to the EMF of the battery minus the internal resistance multiplied by the current. And EMF is the voltage at the battery terminals without load. And the greater this resistance, and the greater the current, the lower the output voltage of the battery. That is, the lower the internal resistance of the battery, the better. Let's take a gel traction battery, which I use together with solar panels. We measure the voltage 12.3 volts, resistance 15 millimeters. Let's try to take another measurement. As you can see, the readings are approximately the same. And let me show you why the contact needs to be clamped, and not the closed contacts of the Kelvin probes pressed against the terminals. Here we take it and install it. As you can see, the resistance is jumping. Let's try again, the same thing. This testimony cannot be trusted. So we take it, connect it again, and again we have the same readings. Therefore, we always clamp the contact. And if this cannot be done, then open the probe and touch it simultaneously with both contacts of the probe. Traction battery, more for working with a stable load, and not with starting currents. Therefore, it is not necessary that the internal resistance will be minimal. But for this battery, 15 milliohms is a good indicator. The minimum resistance is most relevant for starter batteries used in cars. And special devices are used for testing. In addition to the voltage at the terminals and internal resistance, they indicate the starting current, the degree of charge and wear of the battery. Based on this data, the device either offers to charge the battery or reject it. I plan to order such a device and review it. Subscribe to the channel so as not to miss it. Although the internal resistance that such a device shows will also help judge the life of the car battery. But more often this device is used for traction batteries, and batteries for power tools and household appliances. For example, you can check the battery of a phone, flashlight, measuring device, electric scooter, hoverboard, and other vehicles with electric motors. Let's check the 18650 battery from the flashlight. There will be a problem connecting it with these probes. You can squeeze it like that. Here we connect this way. We look at the readings. Voltage 4 volts, internal resistance 63 milliohms. These indicators are good for this battery. This device is usually not used specifically for measuring voltage. Most multimeters provide similar characteristics. But if we decide to measure the voltage, then it is worth considering that it should be a constant voltage and no more than 100 volts. It is prohibited to measure alternating voltage with this device. Let's see how to operate the device. Press the top button. Now we can select the voltage measurement range. We leave the car. Press the down button. Here we can change the resistance measurement range. I also leave the car. When we press the middle key, we freeze the value and can disconnect the probes. Press again and turn off freezing. I hold down the right key for a long time and go to the menu. The first point is interesting for those who deal with a large number of batteries. This is sorting batteries by parameters. Click OK. There are 8 preset values for sorting batteries. Now there is the first preset. We can change it M2, M3 and so on up to M8. Returning the first preset. Now all presets are configured the same, but we can adjust the values to suit our needs. The maximum and minimum voltage values are specified at the top, and the maximum and minimum resistance are specified at the bottom. Using the left and right buttons we can select which parameter we will change. Click OK. Here we can select the number that we will change, and then use the up and down buttons to change this value. Click OK. We have corrected the value. We can also change all 4 values. We measure the battery. As you can see, the green signal blinked. That is, it showed us that the battery passed the test. We take a 1.5 volt battery in advance. Besides, it is discharge. Our red light flashed. This showed that the battery did not pass the test. This way we can quickly check many batteries, weeding out those that do not fit the parameters. To exit the mode, hold down the right button for a long time. The next menu item is history. Let's go in. The testing history is stored here according to the previous paragraph. Conventional measurements with the device do not fall here. This story can be transferred to a computer. Just connect it to the device using a cord, and the device will be detected as an external flash drive. The history will be located on this flash drive in the form of an Excel file, where we can see these values. And we can move this file to the computer. Exit by clicking on the right button. The next item is voltage calibration. For calibration, reference voltages are needed. If you don't have them, skip this point. The next point is resistance calibration. Here, too, standard resistances are needed for calibration. I don't have any. The only thing I can do is calibrate the zero. Moreover, there is no need to hook the probes to each other. We take a conductor and place the probes as close to each other as possible. Click OK. Zero is calibrated. Let's go out. The next item is speaker volume. I put out about a third. You can use the left and right keys to set the volume at your discretion. Click OK and exit to the menu. The next item is setting the clock and date. Click OK to configure. Click OK again. We are first asked to adjust the year. Using the right and left buttons we can select the numbers that we are going to configure. And with the up and down buttons we adjust the value. Then we move it left and right and set up all the date and time values. Once configured, click OK. To exit, press the left menu key. The main thing is not to get confused. In some points the exit is with the right button, and in others with the left button. Next is brightness, adjustable in the same way as sound. We approve. Next is choosing a language. The choice is small. We choose English. The next step is to configure the auto shutdown function. Here we can choose 5 minutes, 15 minutes, 30 minutes or turn it off altogether. Let's go out. Next comes a system reset to factory settings. Here we can see the manufacturer, model and firmware version. I updated the firmware on this device. How to do this can be found in the device passport. I won't do a system reset, so I press cancel. To exit the menu, press the left key. To turn off the device, hold down the middle button for a long time. In general, I like the device, especially that it can measure low resistance. Sometimes you have to deal with this, but there is nothing to measure it with. Battery testing is also a convenient feature. We choose batteries, which ones can be installed in the device, which ones can be recharged, and which ones can be thrown away altogether. The function is certainly necessary and useful. Plus, I like the nice design. A special like to the manufacturer for the rubber feet. This significantly increases the ease of use of the device. If you have any questions, write in the comments. It will be useful if you share your experience with similar devices. I left a link to the device in the description. Share the video with those who may be interested in this device. Subscribe to the channel so as not to miss new videos. Like, and see you in new and old videos.